Hi there, I'm Deim and I am a data analyst. I'm often buried under heaps of messy address data. Addresses are tricky. They come in various formats, abbreviations, and sometimes they're just plain incorrect. I knew there had to be a better way. The main problem was manually cleaning up free text addresses. It was time-consuming, error-prone, and inefficient. I needed an automated solution to standardize and validate addresses. That's when I decided to build VibeClean, a simple web app that utilizes Python to validate and standardize addresses from files using Google Maps search functionality. To stay organized, I created a clear product roadmap structured into 5 key phases. Phase 1. Environment setup, installing necessary tools, Python libraries, and creating a project structure. Phase 2. Backend development, coding file handling, data validation, address standardization, and Google Maps integration. Phase 3. Front-end development, building the user interface, incorporating drag-and-drop file uploads, and visual instructions. Phase 4. Integration and testing, comprehensive tests to ensure robustness, handle edge cases, and improve user experience. Phase 5. Deployment, final adjustments for smooth deployment to Vercel, ensuring seamless serverless functionality. To speed up development, I turned to GenAI for assistance. I used Cursor AI, an AI-powered code editor that boosts developer productivity with advanced features. Here's a demo of my prompts. This prompt asks Cursor AI to build a Python-based web app that allows users to upload an address file, XLS or XLSX, verify each address using Google, and then correct or standardize it. It trims spaces, expands abbreviations, and only replaces addresses if Google finds a better match. If a change is made, that cell is highlighted green in the output file. The front end will be in HTML, CSS, and the backend will be in Python. After processing, users can download the corrected XLSX file via a download button. We went back and forth as we iterated through the entire process and guided Cursor AI to modify the code according to our requirements. But here's our final code. Here's what the Cursor AI responded. This code block imports all the necessary libraries to build and run a Python web app that processes and cleans address data. It uses Flask to handle the web interface, file uploads, and responses. It utilizes pandas and OpenPyXL to read, modify, and format Excel files. It also uses RE for cleaning text using regular expressions. On the other hand, secure_filename ensures uploaded file names are safe, while OS, temp file, and path help manage files and directories. Lastly, lib parse safely encodes address strings for use with APIs, making the app secure, efficient, and ready for real-world data handling. This code initializes the Flask web application and sets configuration options for file uploads. It defines a temporary directory as the upload folder using temp-file, getTempDir, and restricts the maximum file size to 16 megabytes to prevent oversized uploads. It also sets allowed file extensions to .xls, XLSX, and .csv to ensure only supported formats are processed. Lastly, it defines valid column names the app will recognize when reading uploaded files, specifically for address-related columns and state-related columns. This comprehensive dictionary ensures consistent state name formatting across all address data. This code defines 2 helper functions for handling uploaded files and locating the correct data columns. The allowed_file function checks if the uploaded file has an extension and if that extension is one of the allowed types, XLS, XLSX, or CSV. The find_column function searches through the data frame's column names and returns the first one that matches any name in a list of valid names, ignoring case sensitivity. This ensures the app can flexibly recognize column names like address or state even if they are written in different capitalizations. This function, standardize_address, cleans and expands common address abbreviations in a given text input. It first checks if the address is missing or blank, and if so, returns it unchanged. If valid, it trims any leading or trailing spaces. Then, it defines a dictionary of common abbreviations like street or avenue. Then it utilizes a loop that scans the address string and replaces any matched abbreviation with its standardized full version, ignoring case sensitivity. The result is a cleaner, more uniform address string suitable for validation or processing. The same process is done with standardize_state function. It first checks if the address is missing or blank, and if so, returns it unchanged. If valid, it trims any leading or trailing spaces. If the input is already a full state name, case insensitive, it returns it in title case, e.g., California. If it's a valid abbreviation, like CA, it converts it to the full state name using a predefined dictionary called states. If the input doesn't match any known abbreviation or full name, it returns the original value unchanged. The get_maps_search_URL function generates a Google Maps search URL for a given address, optionally including the state. It first checks if a valid state is provided. If so, it appends the state to the address to make the search more specific. Then, it encodes the combined address string using olib parse, !+ to ensure it's URL safe. For example, spaces become plus, commas are encoded. And finally returns a complete Google Maps search URL that can be used to look up a location online. The process_address function prepares a cleaned and enriched version of a given address by standardizing its format and generating a Google Maps search URL. It first cleans the address using standardize_address and, if a state is provided, also standardizes the state using standardize_state. Then it creates a Google Maps search URL based on the cleaned address and state. Finally, it returns all this information in a dictionary, including a Boolean flag called process to indicate whether the address or state was modified during standardization. The save_file function exports a cleaned data frame into either a .csv or XLSX file and saves it to a predefined upload folder. It constructs a new file name based on the original name and chosen format. If the format is CSV, it writes the file directly using pandas. If it's Excel, XLSX, it uses OpenPyXL to write the data and then applies a green highlight to rows that have a processed flag set to true. This visual cue helps users easily identify which rows were modified. Finally, it returns the name of the saved output file. After these backend coding, Cursor AI generated codes for front-end development and even up to deployment. We now have our very own VibeClean tool. Before I demo the tool, let me share some feedback. While vibe coding can accelerate development, it's important to anchor it with a clear plan and structure. At one point, Cursor AI suggested using Google APIs, which, although powerful, would have added unnecessary complexity and deviated from our original project scope. It's also crucial to test the tool at different stages of development. Don't follow AI suggestions blindly. There were moments when we had to prompt it to revise or redo certain elements, like the dictionaries, because they were incomplete or missed key entries. The AI model doesn't yet follow best practices and often relies on brute force approaches. There's still significant room for improvement in data structures, algorithms, and overall system design, but it's evolving, and I'm confident it will get there in time. Lastly, treat AI as a powerful tool, but never neglect the fundamentals. You can't effectively prompt what you don't fully understand. Strong foundational knowledge is what makes AI truly useful. Now, here's a quick demo of the VibeClean tool. As you can see, the addresses in rows 2 and 3 have abbreviations for street and state as well as avenue. Now, open the web app and upload your file. Click on Process File. Wait for it to process your file. Then download the processed file. As you can see, the rows that were processed and altered are highlighted in green. The street, which was initially abbreviated as ST, is now spelled out in full. New Jersey, which was initially abbreviated as NJ, is now presented in full form. We also have a Google Maps URL for the location,